Everybody say good
morning.
There you go.
Morning.
Okay. We're gonna sick as a dog too, so give me a break. All right, we're gonna use similar triangle measurement today. Okay. I think there's a lot of situations out there in the real world that actually use those to find out the measure of things you can't, that are hard to measure. Okay. Similarity theorem, right out of the book. This should make sense. If two angles of A and B are congruent to another triangle, F and G, see the little hash marks, guys? Then if two angles from one triangle are congruent to two angles of another, but that doesn't have any kind of information about it, what do you guys think? Are they congruent? Well, think about it. What is three angles of every triangle? So if this one's the same as that one, and this is the same, I'm doing the math and the 180 stuff, C and H are similar. That's all that thing's saying. You'll learn a lot more about that when you guys are sophomores and in geometry. All right, let's decide whether those two triangles are similar. If so, you're going to write the similarity statement. I'm going to show you guys how to write that. It's easy. Similarity statement. Okay? Let's see. Right off the bat, it doesn't look like the two angles that they give you information about are congruent. One's 85 and 85, but 40 and 55. Everybody use their knowledge of triangles and try to figure out the measure of the missing angle in each one. You can use your calculator if you need to. On the smaller triangle, what's the measure of that angle? And how do you know? How much is it?
Because, like, how you got it.
Say again?
Like, you asked me how you got it.
Yeah, how'd you get it?
85 plus 40, and then you do 120 and 180 minus 125.
Right? Yeah. You don't know? So that one's 55. Do this in the other one, guys, and see what the missing angle is. What is it?
40.
By the same basic rule that three angles always add up to 180 in a triangle. So now look at them. Are the two triangles similar?
Yes.
Why?
Because they all have the same degree of.
Yeah, because the angles are all congruent, okay? This one, guys, it was a 90-degree rotation on it. That's what I did. I took this one and turned it 90 degrees. So you say they're similar. Okay, that's half the battle. And now we're going to write that similarity statement. Okay? Triangle. Here's how you label a triangle. You put a cute little triangle symbol. Triangle. I'm going to go in alphabetical order. A, B, C. Okay? And then what does the similar symbol look like? Does anybody remember from Friday?
Like squiggly lines and.
One squiggly, right? Is similar to. Okay? Now, it's real important how you label this one. No, I went A, B, C. So I went the 85, the 55, and the 40. Who can tell me, matching those angles up just like we did from ABC, how does the other triangle work? See if you can do that. Go ahead, Chuck Smith.
DFE.
I think it's
DEF.
DEF. Triangle. DEF. And that's the second half of the battle. Naming the similarity statement. And the order matters. A, B, C, 85, 55, 40, D, E, F. Okay? So that's part of your homework. You're going to have to find out, are the triangles congruent, not congruent, are the triangles similar, and state the similarity. Okay. All right, try that next one. Find the missing angles and decide if they're similar or not. Those are two right triangles. Nina, what's the measure of the missing angle in the small one?
Nika.
What is the Nika, not Nina, Nika. What is the measure of the missing angle in the small triangle? I got 60 degrees. Very good. Okay, she did probably like 180 minus 90 minus 30. What's the measure of the missing angle in the other one? Use your calculator. Go ahead, Val. 40 degrees. Very good. Okay. Similar or not similar, guys? Why not? Yeah, because the angles are not congruent. Very good answer. So it's not similar, and then there is no similar statement, similarity statement that you can write about it because they're not similar. If you just say not similar, you're done. That makes sense? You got a couple problems like that in your homework. Decide if they're similar, go from there. Now, if they are similar, okay, got this up at the top. If similar, sides, okay, underline the word sides, are, what's the word that goes after that? We'll complete that. If the triangles are similar, what are the sides? Are they congruent? They're not congruent because one's bigger than the other. So what's the word that would complete that statement there? What do you know, Anthony? Say again? I don't understand what she's saying.
Dilated.
Yeah, but what would be, they are dilated, but what would be, what are the things we set up, guys, to solve for all these problems? Sides are proportional. That's how we're gonna solve these. If the triangles are similar, the sides are proportional. Okay? And that's the whole, you set up a blank proportion and you're gonna be given 3 lengths and usually 1 variable. You're gonna solve for your variable. Okay? You can use similar triangles, proportions, and indirect measurement to find the lengths of measures in these figures. There's always like a tree or a flagpole, something really tall that we can't measure. It's hard to measure how tall a tree is. Okay? So that's the kind of problem we have. You can always measure a dog. A dog's not very tall. Okay? Now, what they're saying here is, you can draw a little sun up there. There's always these shadow problems. When the sun shines down on things, it casts a shadow. Does everybody agree with that? There's these. Now, here's a tree. There's its shadow. And if you draw the hypotenuse in, you got yourself a right triangle. A dog's height, a dog's shadow. Drawing the hypotenuse, you got a right triangle.
If a shadow, so if 2 objects next to each other the shadows are always proportional? Is that what we can say?
Yeah. Yeah, the shadows and the figure made are proportional. Okay? So, even with the tree and a dog, do you guys see what the triangles in there? Yeah. Okay. Let's set up a proportion to figure out how tall the tree is. They labeled it at h meters. The shadow of the tree is only 2.2 meters. The dog's 0.45 meters tall. Its shadow is 0.3 meters. Okay? Everybody use those 4 numbers and try to set up a good proportion. There's a lot of good proportions that you can set up there.
Before I started, I always try to decide what am I going to put on top and what am I putting on bottom. I always put a label to the left.
Okay.
What do you? So, but you can decide that, right? It doesn't matter. But what are you guys going to put on top? Okay, so you want to do the tree? Do the tree figures?
Tree over the dog?
Okay.
You don't have to do it that way. If another way makes sense to you, do it that way. Okay? I always start with the variable.
Oh, okay.
I always go right to the, guys, the first thing I do is,
Excuse me, Mr. Pancini?
yes, good morning.
Morning. Is Scott in class?
He is not.
No, thank you.
You're welcome. All right, so I always start with the variable, guys, just because that's what I'm trying to solve. So I put h at the top left. What goes with the h
2.2.
in the other? Well, so I think that goes to the right. But you totally could put the 2.2 down. Do it that way, Charlie, and watch how it works.
You do it that way, he's going to do it.
I'm going to do it a different way. Abigail, what goes with the h in the dog part?
0.4.
0.45. 0.45. So she did tree over dog. Now, Abigail, what would go on the right based on the way you got that set up so far? You're doing great.
0.3.
Do it that way.
Oh, 2.2.
Yeah, because you went with the h at the top, so you got to go with the 2.2 at the top. Over 0.3. Is that the only proportion in the world, guys, that works? Look what Chuck. Here's what Chuck tried to do, I think.
Yeah.
Nope.
Go ahead, Chuck. What was it?
On an h over 2.2
Watch this, people. Equals.
equals 0.45 over 0.3.
Look what's diagonal from each other in both in the red and the green. Look what's diagonal. Same stuff. Okay? So, depending any way you solve this, it's going to be 0.3h equals, and now everybody grab your calculators and type in 0.45 times 2.2. Val, how much is that?
99.
0.99? That's right. Divide both sides by 0.3. Leave that 0.99 on your screen, people. Help yourselves out. And then just hit divided by 0.3. Val, what did you get?
3.3.
3.3, that's what I got. 3.3 meters. So even though that tree looks pretty tall, it's only like 10 foot tall. So that's what you guys are going to do today. You're going to look at a situation, you're going to set up a proportion, you're going to solve it. It's really easy today, guys. All right. Some of them, though, they don't give you a picture. They don't give you a picture. They kind of give you a situation. JB, read us example 3 loud and proud. The first example 3.
Rocco is 6 feet tall. The shadow is 4 feet long. The nearby flagpole casts a shadow that is 22 feet long. How tall is the flag?
Okay. You don't have a picture, guys. What should you do? Draw a picture. Here's what I did. I drew a picture of Rocco. Okay, there's Rocco. I probably drew him too big, but that's okay. Okay. So the sun is shining down on Rocco. When the sun shines on him, it makes a shadow. That's what's going on. It's just like the tree and the dog situation. Now, without doing any work, does anybody know, is the flagpole taller or shorter than Rocco? Well, we assume it's, but why is the flagpole, do you know with the numbers there, why do you know the flagpole's a lot taller? Because the shadow's a lot longer for the flagpole. So, draw a flagpole. Doesn't have to be perfect. And there's its shadow. So the sun shines down on the, okay? Now let's see if you guys can put the numbers in the right spots. Okay? Try to put the 6, the 4, and the 22 where they go. Read it carefully. JB did a great job of reading it. Moss, where's the 6 go? On the side of Rocco. Very good. Where's the 4 go?
On the bottom.
Yeah, his shadow. Where's the 22 go?
On the bottom.
On the bottom of the flagpole. Then, what are you going to put for the flagpole? X, or any variable you want. We do not know how tall the flagpole is. Okay? Rocco's 6, his shadow's 4, the flagpole's X, the shadow's 22. Use those 4 pieces of information, the 3 numbers and the variable. And write a good proportion, guys. Everybody here can do it. Perfect, Sean Kelly, what proportion did you write?
X over 4.
That's the only one you can't do. Look what he's trying. Look what you're doing. You're going the flagpole with the Rocco's shadow. Those don't go together.
X over 6.
Yeah, you got to go the same. X over 6.
Is 4 over 22.
Can't do that. 22 over 4. Okay, because you started with the flagpole, Sean. You got to do flagpole over Rocco. You're going to do it that way. Okay? Is that the only one that works, guys?
No.
Anybody got another one they think works? Jeej, what'd you write?
6 over x equals 4 over 22.
Yeah, you just did the reciprocal. That's great.
I have another one.
You got another one? Chuck?
F over 22. X over 22 equals 6 over 4.
Perfect. Guys, look what's diagonal from all of them. And all 3 of those, the same stuff is diagonal. So when you write the equation and solve it, it's going to be the same stuff. 4x equals 132. Divide by 4. The flagpole, I got to be 33 feet tall. Okay? Be careful, set up your proportion. Look at how things match up. Do what makes sense to you in your head. All right. So there's always, like I said, there's always shadows and stuff. But then there's always distances across lakes. You can't measure the distance across a lake. You really can't drive across a lake unless you get in a boat. Okay? There's always the lake distance. Do you guys even see two triangles there? Or do you see one? Where's two triangles? Yeah. You get the big triangle, ACE, and then you get the little triangle, ABD. Okay? Those are the little one inside the big one. Okay? All right, now we know that length and we know that length of the little one.
Yeah,
We
I
know.
guess the link didn't show up on your,
Oh, it didn't?
in their copy, it didn't show
Ah,
up.
got it. You guys draw a little sneaky lake in there. Like, some of you guys did that already. For D, there's supposed to be a lake there. Sorry about that. But you don't know the length of the long hypotenuse side of the big triangle. How could you figure that distance out? How far is it from A to C? What do you do with them? Add them. Everybody type in 320 plus $1.62, and that's how long A to C is. And you gotta do that first. How long is it from A to C? 482. That's what I got. Does everybody see why we have to do that? Now we got a lot of numbers up there. Okay, I'm gonna do big triangle over small triangle. Everybody try to set up a proportion. See if you can do it. You don't have to go big over small. Do what makes sense to you in your head. When we got a proportion that you think that's right, let me hear it. Anybody? Not gonna move on, guys, until somebody takes the risks and shares what they got. Go ahead, Lily.
D over 40.
Hold on. Great. D over 40. Look what she did. She matched up the right side of the big with the right side of the little. What do you think?
Yep.
That's great.
And then, oh, I did this wrong. 320 over 42.
Wrong way.
Oh, 42 over 3.
Right? Because you went big over small. You got to continue to go big over small. 482 over 320. Okay? Look at the proportion you guys wrote. You better have the D diagonal from the 320 and the 40 diagonal from the 482. Okay, that's the only thing that'll work. All right, we got big numbers here, but we can deal with this. 320D equals 19,280 divided by 320. Leave that number on your screen, people, if you're using your calculator, divided by 320. Now what'd you get?
60.25.
Label it, 60.25 what? Meters. Okay? So that's a really small pond. It's not too big at all. All right. Well, that's it's not going to be meters. I don't think it'd be miles. All right. So draw pictures tonight, guys. Set up proportions. Use your calculators. Okay? Everybody say goodbye.
Bye.